Alright, I've been working for the perfect debunk on general relativity, and my previous two videos aren't that solid. This one I think is irrefutable. I have the physicist here, and we're going to be following his exact instructions, and we're going to be proving that general relativity is empirically false. Okay, we're not going to be looking for a theoretical error. We're going to be showing you that there's an empirical error in general relativity. So let's get into this. All right, so the Berkeley physicist says here, I would ask ChatGPT. ChatGPT is, quote, very good at physics, and I use it a lot. Okay, so we're going to use ChatGPT, and it should give us pretty reliable information. So this is the equivalence principle of Albert Einstein here. And it states that there is no experiment a person could do in a small volume of space, and he uses an elevator as an example, to tell apart a gravitational field from an equivalent uniform acceleration, and he means this locally, okay? So if you're in this elevator with no windows, no GPS, there's no way you could do any experiment to tell if you're sitting on Earth or on this elevator accelerating in space. So, you know, you can pull up your AI right now and ask it if that's an exactly perfect description of the equivalence principle, and I guarantee you it'll say that's exactly right, okay? So, therefore, he reasons that since light bends in an accelerating elevator because the wall moves up, it also bends on a stationary one on Earth because these are locally equivalent, meaning the physics in both rooms are identical. So think about it for a second. That should make sense, right? Because as you fire this beam of light sideways, right, the floor of the elevator is actually moving up. So the spot it hits on the wall is a little lower, like there, right? And so he reasons the same thing is true here, right? Anyways, let's just accept that. Okay, so here is why the equivalence principle is empirically wrong, okay? So this is proven by the Eddington eclipse. Now this here is the original version of the equivalence principle, but the Eddington eclipse actually showed that Einstein's math was off by a factor of 2. So Einstein had to change his math, so he added in this thing called space-time curvature, and this is why the stationary perspective, the light bends twice as much. So the Eddington eclipse showed that in a gravitational field, light bends twice as much as he would have predicted. And the prediction was based on the equivalence principle here, on the equivalent uniform acceleration. So now we just simply ask ChatGPT, you know, is that true? Well, you have to do a little bit of back and forth, but ChatGPT says right here, yes, it's true. The elevator sitting on Earth, the light is going to go lower by a factor of 2 than it would on this elevator in space accelerating, okay? That proves the point, which is that these two are not equivalent, okay? There clearly is an experiment we could do here to tell the two apart, and it's the actual bending of light, right? So the light bends twice as much on the stationary elevator on Earth. Okay, so that is a really, really huge deal, all right? That's not some small little detail. This literally proves the equivalence principle is wrong, and the equivalence principle is just factually false, all right? So how do physicists reconcile with this? And I'm not joking, this is what they actually do. So what they do is they take this elevator and they shrink it. They say, okay, well, Einstein has to be right because he's an all-perfect deity. We can't just admit his math was totally wrong and off by a factor of 2. So we shrink the elevator. We shrink it more and more and more and more until it's a zero-dimensional point. This is actually what they say, and that's according to ChatGPT. So they shrink it till it's a zero-dimensional point. And then they say, well, okay, 0 times 2 equals 0, and 0 times 1 equals 0, right? So now they're physically the same, right? So our light, because it only can hit one point now, it's a zero-dimensional point, it can only go to one single spot. This argument is absolutely comically ridiculous, though, because the same thing would be true if light were bending 10 times, right? If it were bending 10 times more in the gravitational field, this shrunk elevator would still be true. If it was bending 100 times more, it'd still be true. 0 times 100 is still 0. And the funny thing is, the whole idea of the equivalence principle is that based on the way light bends, in this space elevator, you can determine how it bends on Earth. But now that's no longer true. This is now factually false, right? When we shrink it down to a zero-dimensional point, the light doesn't bend at all in the space elevator. So the conclusion we should get is that it also does not bend at all in the gravitational field, right? Because it just moves on this one single point. You can't have a bend if you only have one point. You need at least 2 points to make a bend, right? And this whole idea of gravitational time dilation is based on the equivalence principle. So it's a very interesting thing, because I've looked a lot into GPS, and to me it looks like the GPS formulas that Einstein made are actually correct. So how on earth are those right when the core principle they're based on is actually wrong? It's an interesting question. And I think the explanation is that Einstein just didn't use the equivalence principle. I think he figured out some other way that, clocks are slowing down in space. And then he just framed it as like this magical equivalence thing to, make it sound better, all the space-time curvature and four-dimensional stuff. That's what sells the idea. That's why Einstein is famous and not just another George Sagnac. You probably never heard of George Sagnac or Ives Stilwell, right? They discovered similar things, similar physics, but they're not super famous, right? Whereas Einstein became this super famous guy because he sold all this physics with all this magical space-time stuff, okay? So, anyways, the point is general relativity is obviously wrong because it's based on this equivalence principle. Okay, what do you think? Does that debunk general relativity really well? I mean, I'm following the physicist's exact instructions here. I don't know how you can really argue against that. These physicists are smart guys. This is Berkeley. This isn't, some small community college either, right?